Okay. This is a bell-shaped curve, as you can see, guys. And he gives you the mean of this data set to be 22. And where did we say the mean should be? Should be right in the center of the data set. So this is the mean, guys. Right here. That's 22. He says the standard deviation is 3. Okay, label the mean and 3 standard deviation from the mean. Here's what we're gonna do. When you label an x-axis, guys, you add numbers this way and you subtract numbers the other way. So if you go to the right, I wanna increment by 3. And for a reason, he says the standard deviation is 3. So if I increment by 3, this will be 25. That will be 28. And this one will be 31. Okay, let's do it the other way. What do you think the number is gonna be right here, guys? Yes, what is it, 19? Yep. Then 16, then 13. Remember, this is a bell-shaped curve. The mean is always right at the peak. It's right here. And the bell-shaped curve, guys, for your information, extends from the mean as high as 3 standard deviation to the right and 3 standard deviation to the left. And that should cover pretty much the entire data set. So in real life, guys, you need to know this fact. Probably this is gonna surprise you. If the mean, let's say I give you a test, and the mean, the average score, just 1 second. If the average score on the test was 70 and the standard deviation was 8, I can tell you what the lowest and the highest score are going to be. Take the 8 and multiply it by 3, that will be 24. Add 70 to 24, that will give you 94. Now take the 8 and multiply by 3, that's 24, and subtract the 24 from 70, that will give you 56. So most of the scores, guys, are gonna be between 56 and 94. In real life, when your data looks like a bell-shaped, you don't go above 3 standard deviation. Everything stays within 3 standard deviation. Now here, you notice, guys, the curve is covered from a low of 13 to a high of 31. Where did I get those numbers? He gave me a standard deviation of 3. What I did the mean, added a 3 here. Then I added a 3 here. Then I added a 3 there. Then subtract a 3, subtract a 3, subtract a 3. It's within 3 standard deviations. So when you have a bell-shaped curve, I want to share those results. They're based on experiment. 68% of the observations, 68% of the data fall within 1 standard deviation of the mean. If I go to this example, what is within 1 standard deviation of the mean? The mean is 22. If I add 1 standard deviation, is 25. If I subtract 1 standard deviation, is 19. So 68% of the values in the data set, guys, are gonna be between 19 and 25. You ask me why? This is based on experiments, but later in chapter 5, that will become a fact. But for now, we're just gonna accept it as it is. 95% of the observations fall within 2 standard deviation of the mean. Now, what does 2 standard deviation mean? You take 22 and add 2 3s, you take 22 and subtract 2 3s. If you do that, guys, you're gonna end up between 16 and 28. So you can say 95% of the data lie within 2 standard deviation of the mean. Now look at the last one. 99.7% of the observation fall within 3 standard deviation of the mean. It's almost 100%, but it's not 100%. So 3 standard deviation below the mean, it's as low as 13, as high as 31. So you can, guys, be sure that most of the data is captured within 3 standard deviation of the mean, but not all of it. It's 99.7%. Can you guys tell me what happens to the 0.3%? Why this is not captured, you know, in the data set? Any ideas? You should go back and think of what we've done. What is the 0.3%? Who are they in the 0.3%? Any ideas? Yes, I saw, oh, great. I saw 3 comments from students, outliers. These are the outliers. These are the ones that don't belong there. I'm gonna give you an example of a 0.3% value that will not be picked up, you know, by this curve. Let's say, guys, I give you a quiz out of 20 points. Every single student scored between 18 and 20, and one student got 1 or 2 out of 20. This 1 and 2, guys, is not going to be captured, you know, just by the 99.7% because it's an outlier. An outlier doesn't have to be large. It can be very small or can be very large. So that's why within 3 standard deviation of the mean, you guys can pick up most of the data as long as your data is bell-shaped. If it's not bell-shaped, whatever we did here does not apply at all. Okay, so this is the summary. They call it the empirical rule. It's called the 68, 95, 99.7% rule. 68 refers to 1 standard deviation, 95 refers to 2 standard deviation, and 99.7 refer to 3 standard deviation. The only thing that I want you to know in this part is just understand what 68, 95, 99.7 mean, and that would be it. Now, let me show you some applications, guys, on this. Let's answer, you know, some of the questions right here. What percent of the scores are between 16 and 28? We just did it anyway. 16 and 28, guys. From 16 to 28. You agree with me, from 16 to 28, it goes 2 standard deviation below the mean and 2 standard deviation above. Well, we already defined that to be what? 95%. So that will be a 95%. What percent of the scores are between 19 and 22? Can someone? Yes. Any questions here? Okay, what do you guys think between 19 and 22? What the percent is? Okay, I see some replies in the chat. Let me check. Oh, 34, very good.
Half of it.
Yeah, you guys know why the students say 34? Because 1 standard deviation is 68, but remember, 1 standard deviation above and below. This is only below, so it's half of 68. I agree. Okay, let's do one more. This is going to be the harder one. Between 16 and 25. Let me.
81.5.
What is it?
81.5.
Yes. This one. That's 81.5% of the data, but let me explain why. Definitely you're asking, how do we know? Okay, let me show you. It is indeed, it turns out to be 18.5, and let me explain why. Okay, I'm gonna just do them in pieces. So this one, guys, this one is 34% because from, it's 1 standard deviation above the mean, so that's a 34%. Okay, now I'd like you to look. Let's hide this. Okay. Well, this part, guys, do you agree with me that it's 2 standard deviation below the mean? 2 standard deviation below the mean should be half of the 95% because 95% is 2 standard deviation below and above. So that's half of 95. Well, let's add them up. Half of 95% is 47.5. And 34%, as you said, it's 81.5%. So this is what we call the empirical rule. The type of questions, there's going to be probably one question in the homework, you know, just covering this one. Just give you an example. This is the mean. You can tell, can you guys tell what the standard deviation is here without even saying? Can a student tell me what the standard deviation here is? The mean is 10.
2.
2. Well, this is the increment. You increment by 2. Okay, here's a question. What percent of the data is between 8 and 12? Well, you know, between 8 and 12 is one standard deviation above and below the mean, it's 60, 80%. That's it. So it's another, you have to memorize those values. But later in chapter 5, you can see, guys, that we don't need to memorize anything. We'll figure out, you know, how to calculate those percents. So this is the empirical rule. And remember, the empirical rule, there is probably a true or false question in the homework. The empirical rule applies to any data set. False. It only applies to data set that are approximately what? Bell-shaped. If your data set is not bell-shaped, if it is something like that, guys, you cannot apply the empirical rule. It has to be bell-shaped, symmetric. Okay. And now, the last section, very easy section. We'll go through it, and then we'll do a little bit of a review of chapter 2, if time permits. Okay. I'm going to begin with the example explaining measures of position. We have a data set right here. Here are the travel time in minutes for 15 workers in North Carolina, chosen at random by the Census Bureau. If I want to find the median, guys, the first question is to find the median. Well, you need to sort the data set in order. Here is the data set. For your convenience, I sort it in order for you. Well, let's find the median. The median is the value in the middle. So I have 15 values here. If you add 1 to 15, 16, divide by 2, you get 8. So it's the 8th value. 1, 2, 3, 4, 5, 6, 7, 8. That's the median. Okay. If I want to find the lowest value is 5, guys. The largest value is 60, but he wants us to find the first quartile and the third quartile. Let me define the first quartile. The first quartile is the middle of the first half of the data set. So it's the middle of this. Can you guys see where the median is going to be of the first half? It's going to be right here. How did I know that? I have 7 values. Add 1 to 7, 8, divide by 2, 4, count 1, 2, 3, 4. This is called quartile 1. So that's a Q1. Okay, now he wants the third quartile. The third quartile is the middle of the second half of the data set. So the middle value in the second half. Here's the second half, guys. And where would be the middle? Right here. And this is called the Q3. Now he wants you to find the minimum and the maximum. This is the minimum. And this is the maximum. So how many numbers did we find? 1, 2, 3, 4, 5. And look what the question is. Find the 5-number summary. Your calculator will do it for you if you key in the data. But be honest with you guys, when you have the data sorted in order, it's very fast to do it. So the median is 20, which is called, guys, Q2. The first quartile, which is called the Q1, is 10. The third quartile, which is called the Q3, is 30. The minimum value is 5, and the maximum value is 60. Any questions here about the 5-number summary? Feel free to unmute yourself, guys, talk to me, or send me a text in the chat if any questions. I'll check the chat very often if any questions. Okay. Now, after finding this, we're going to learn how to do a box-and-whisker plot. So in order to do a box plot, you need the 5-number summary. Well, online, since this is 100% doing homework online, you're not going to be asked to draw a box plot by hand, but he will give you a data set and will give you 4 or 5 box plots, and you need to figure out which one would match, you know, with your data set. You will be able to use a static crunch to draw the box plot, but I'm going to show you how the box plot works by hand. Here's how you do it by hand. Let's watch. This is, you draw a number line. You figure out what the minimum value, which is 5, and the maximum 6. You need to scale this one so you can show the 5 and the 60. Here's what I'm going to do, guys. I'm going to do 0, 10, 20, 30, 40, 50, 60. All right. And now let me show you how to create the box plot. You go to the minimum value, which is 5, and you put the dot right about 5. So this is the 5 right here. So you just go here and put the dot here. Then we need the first quartile, which is 10. So it's right here. Then the median is 20. Watch. Third quartile is 30. And then I have 60. Okay, look. Box-and-Whisker plot. We need the whiskers. The first 2 points from the left connect using a whisker, and the last 2 points on the right connect using a whisker. Now you do a vertical line like this, a vertical line, and connect them using a box. This is called a box-and-whisker plot. Okay. A question for you guys. By looking at the box-and-whisker plot, can you tell if the data is symmetric or not symmetric? You should be able to tell from the box plot if the data set is symmetric, is bell-shaped or not. My answer is no, but how do I know that? It's
skewed to the right.
It's skewed to the right. How did you know that? That is correct.
Because there's a longer line on the right side.
Exactly. It's a longer whisker on the right side. Exactly. In order for this one to look symmetric, guys, that should have been that much right here, up to here. Then it would look symmetric, but it's not symmetric. It's skewed to the right. So you can say a lot about the data set from the box and whisker plot. Now, let me tell you about the percentiles, guys. I think you're familiar with it. You heard about it, but we just need to introduce it here. Let's say if I tell you after I compile the results of the first test, I tell students that you scored in the 90th percentile. It means that these students did better than 90% of the students, but the other 10% did better than him or her. 80th, you score in the 80th percentile. That means your ranking is 80%. That means you did better than 80%. You're above 80% of the students, but 20% of the students are above you. The first quartile, guys, is the 25th percentile because it's a first quarter, 25 cents, 25%. So the first quartile, Q1, it's called the P25. P25 means 25th percentile. P stands for percentile. The second quartile, which is the median, it's a P50. And I'm sure you can guess what the Q3, guys, is going to be. It's a P75. It's the 75th percentile. We're more interested in the special names of the quartile 1, quartile 2, and quartile 3, rather than working with percentiles. One more definition I'd like you to know, also what we call the interquartile range. The interquartile range is the difference between the third quartile and the first quartile. So it's a Q3 minus Q1. And they call it in the book IQR. I stands for inter, Q quartile, and R is range. Okay. I'm going to do one more exercise on finding the 5-number summary. You have a data set, guys, here. And we're going to check if there are outliers as well in this data set. Okay. I have 20 values. To find the median, you divide 20 by 2, we get 10. It's between the 10th and 11th. This is the 10th value, guys, and this is the 11th, and this is why you see that line in here. This is your median. Well, it's not one of the two values, so you just add them up and divide by 2. There you go. First quartile, Q1. It's the middle of the first half of the data set. Well, I have 10. The middle between will be between the 5th and the 6th. 1, 2, 3, 4, 5, 6. It's right here. So it's 15. The second one is also between the middle of between 5th and 6th. 1, 2, 3, 4, 5, 6. Between 40 and 45. Halfway through, it's 42.5. The minimum, guys, is 5, and the maximum is 85. Any questions here about the 5-number summary? You always, guys, if you don't want to do it by hand, you can key in the data set or open it in StatCrunch and it will do it for you. Now, the last part of the 5-number summary is how to check for outliers. We talked about it last time that they do affect the data set. So if we have outliers, we usually don't use the mean, we use the median instead. But if we don't have outliers, we can use either one, mean or median, should be a good measure of center. But how do you check if there are outliers? In your opinion, guys, look at this data set. Which number do you suspect to be an outlier here?
85.
Okay. So you suspect 85 is an outlier. Let's check. I'm going to walk you through the process of checking whether this is an outlier or not. So please pay attention to this. I'm just going to do it once, but it's a very easy process to find out whether, maybe some students might argue, say, well, 85 is not too far from 65, so maybe it's not an outlier. So we'll see. Probably it is. Well, I'm going to walk you through the steps. That's why I put step 1, 2, 3 here. And this is at page 12 here. All right. Step 1, find IQR, which you already have a Q3 minus Q1, which is 42.5 minus 15, which is 26.5. Good, that's the first step. You always have to begin with this one. Step 2. Multiply the answer in step 1 by 1.5. And it's always 1.5, regardless of the problem. So it's 1.5. So 1.5 times 26.5 is 39.75. Are we good so far? So that's step 1, that's step 2. And the last step, before I tell you if we have an outlier. Take a Q1 and subtract 39.75, the answer that you got in step 2, and take a Q3 and add 39.75. So let's do this. What is a Q1? Q1 is 15 minus 39.75, which is what, guys? Negative 24.75. I'm going to circle this. That's a very important number. Then I'm going to go to the next one. Q3, guys, is 42.5 plus 39.75. And what is it going to be? 82.25. That's step 3. Now, let me tell you how to find if a value is an outlier. You look at the values in the data set. If they fall between those two numbers, they're not outliers. If there are any values that does not belong, to this range of values, then it is an outlier. Do you guys notice that one of the values does not fall in this range? Which one of you said 85, and I do agree. 85, guys, is more than 82.25. If it is more than 82.5 or less than negative 24.75, then it is an outlier. So 85 is an outlier. Here, anything in between, not outlier. Here it is an outlier. And here, this way, it's an outlier as well. So 85. Any questions about how to figure out if a data value is an outlier or not? No questions? All right. So this is finding outliers. I don't think StatCrunch will tell you whether a value is an outlier or not. So I think you have to go through the process. But as you can see, guys, it's not a tedious process, very fast. You just do it, and this is how you figure out. Don't guess it. If there is a question online to check for outliers, don't try to guess it and say, yes, it is or not, unless if you have a data set like the following. If I give you a data set like they have the following numbers, 2, 3, 3, 4, 7, and then all of a sudden I put the number 200, yeah, you can be sure that this is going to be an outlier. But if I put 2, 3, 3, 7, 8, and then I put 14, don't assume that 14 is going to be an outlier. It could be, and probably it will not be an outlier. So you have to go through the process. All right. So this is, we have one more part in section 2.5, and we'll be done with chapter 2. Okay, what I'm gonna do, we're gonna do this together, guys, and I'm gonna pause the recording as you do this. We're gonna just practice the use of the calculator to find the mean and the standard deviation. So practice what you have learned, use your TI-84. State whether the data in sets A and B represent sample or population data. Then find the range, the variance, the standard deviation of each set. Use the standard deviation to compare the variability between the data sets. Well, there's one question we can answer before you use your calculator. Does the data represent a sample or population here? These are the wait times on rides in Disney, probably. Ride A and ride B. What do you guys think? Sample or population, what we have?
A sample?
Definitely it is a sample. Because, you know, a ride will have millions of millions, you know, just of riders that used it. So we only have 6, 9, 12 wait times from each ride. You know, there is a lot more than 12 people who would do the ride. So it is a sample, definitely. I'll tell you guys, unless if he says it's a population, I can tell you 99% of the time your data comes from a sample. We use samples. Okay, what I'd like you to do, guys, I would like you to put the data from ride A in L1, and I'd like you to put the data from ride B in L2. And to do this, I'm gonna demonstrate that to you on the calculator. Turn it on. I'm gonna clear this screen. It should look like this. Go to stat right here. Edit. And then this should be empty on your side, guys. Start entering the data. I already have it there for you, so just to save time. And then L2. I'm gonna clear L2, so L3, so that doesn't confuse you. Okay, let's enter the data. I'll give you a couple minutes to enter the data set, guys, before we answer the question. Let's do it. So here's how we use the calculator, guys. You go to stat, edit. Oops, sorry, not stat edit. We already done that. Stat calc. One variable is statistics. Okay, I want a L1. Well, it says L3 here. I don't want L3. Look what you do, guys. Press on the second key, number 1, and hit calculate. Okay, take a record of the standard deviation. It's not sigma, guys. You are using a sample here. So S is 14.5. And the minimum is 11 and the maximum is 60 because we need it for the range. So S is 14.5. I'm going to call it SA is 14.5. And the range of A is 60 minus 11, which is 49. Maximum minus minimum. Next, write B. Go to stat, calc, one variable statistic. And my data is not in L1, guys, now. It's in L2. So we're going to do L2. Second and number 2. Okay, my S is 6.5, not sigma. That would be a wrong answer if we put sigma, although they're close, 6.5. And I have my minimum is 31 and my maximum is 50. Okay, 6.5. And we said maximum is 50 minus 31, which is 19. Let's answer the question now. Which set is more variable than the other, guys? Is it write A data or write B? You're gonna help me with this one.
Is it right A?
Write A is more variable. How do you know that? That is correct. Write A is more variable. Write B is more consistent.
Because the standard deviation.
Because of the standard deviation. It has a higher standard deviation. Write A has more variability. And that's not a good thing, guys, because it has a higher standard deviation. So I'll tell you what, guys, if these two rides are exactly the same, and I'm given a chance to choose between waiting for ride A or ride B, I will choose ride B because it's more consistent. It's likely that I'll be waiting pretty much the same amount of time, just like everybody else. Whereas with ride A, the difference between two values could be as high as 14.5 minutes, you know, the variability, whereas in ride B, it's only 6.5. You also notice, guys, the range in A is 49 and the range in B is 19. That's another thing that tells you that ride B is more consistent than ride A. So I thought to just do this exercise and just a chance to go over the use of the calculator in this one. Okay, the last part, which is the part that's gonna be with you for the entire remaining 6 weeks of the semester, the Z-score. I'm gonna introduce that. It's very easy concept, but you need to learn it and you need to learn it very, very well. So if you walk out of today's lesson knowing what the Z-score is, that's a very good thing. Let me give you an example before I explain what the Z-score is. We have a bell-shaped curve. Here is the mean. I'll make it up. Let's say the mean is 40. And I'm gonna put a standard deviation sigma. I'm gonna make it 10 for convenience. So I'm gonna label the graph. The graph is labeled, guys, with 3 standard deviation to the right, 3 standard deviation to the left. It will pick up 99.7. So that's 10, that's another 10, and that's another 10 toward the tail. That's a 10, that's a 10, that's a 10. So 30, 20, 10. And this one, guys, 50, 60, 70. Let me ask you some questions here. And then as you answer them, I'll be able, just to state the definition of the z-score, what the z-score is. Okay, if I take this value right here, 50. What's the difference between 40 and 50? The difference between 40 and 50 is 10. Is 10, how many standard deviation is 10? Do you guys agree with me that 10 is one standard deviation because sigma is 10? So we can say that 50 is one standard deviation above the mean. Do you guys agree with this statement that 50 is one standard deviation above the mean? Because simply it is 50, and the difference between 40 and 50 is 10, which is one standard deviation. Let's take 30. What's the difference between 30 and 40? It's 10. But remember, this is a 10 not above the mean, it's a 10 below the mean. We know one standard deviation is worth 10, so this is one standard deviation below the mean. One standard deviation below the mean. I'm gonna take 10 here. What's the difference between 10 and 40, guys? The difference between 10 and 40, we always compare to the mean. We always compare data to the mean. If we know what the mean is, we always compare to the mean. What's happening, just around the mean. So the difference between 10 and 40 is 30. And 30, how many standard deviation is this? Each standard deviation is worth 10. So would you guys agree with me if I put this statement here? This is 3 standard deviations below the mean.
Yes.
Okay, so that's a 3. Each standard deviation is worth 10, so 3 times 10 is 30. One more, and then I'll write the definition. I'm gonna take 60. You guys agree with me that the difference between 40 and 60 is 20. And 20 is twice of 10, so this is 2 standard deviation above the mean. When you label a number as how many standard deviation this number is above the mean or below the mean, you are talking about the z-score. It's called the standardized z-score. So the z-score, guys, tells us how many standard deviation above or below the mean the data value deviates from the mean. That is the definition of the z-score. So I'm gonna write it down. How many standard deviation a value deviates from the mean? Now, guys, rather than doing all that work to find how many values does it deviate from the mean, how many values above, I'm going to give you a very simple formula. Watch this formula. Here is the formula for z. It's the value minus the mean divided by the standard deviation. Let's see if this formula works. Okay, let's see. What did we do here? For 30, we said one standard deviation below the mean. Let's see if we'll get this answer here. The value is 30. Watch, guys. Minus the mean, which is 40, divide by 10, which is the standard deviation. You get negative 10 over 10, which is negative 1. A z-score, guys, of negative 1 means the value is one standard deviation below the mean. So negative means below the mean, and positive means above the mean. Let me take another value. Let me take x equals 60. We get 2 standard deviation. When x is 60, which is the value, z equals 60 minus 40 divided by 10. You get 2. This is 2 standard deviation above the mean. So this is the formula. The formula is the value, the actual value, minus the mean, which is given to you here, which is 40, and standard deviation, which always will be given to you, which is 10, in order to convert to a z-score. Let me ask you a question now. If I tell you your z-score on the test was 0, what does that mean? We could have a z-score of 0.
Doesn't that mean you did the same as the mean?
Exactly. That means if you're not deviating from the mean, because the z-score is how many deviations from the mean. If I tell you your z-score is 0, don't be alarmed. It's not a bad thing if the average was good. So your score is the average of the class. Z-scores, guys, should not exceed 3 or -3 from the negative side. Why? Do you guys know why I'm saying this? Usually they should not exceed 3. So we rarely hear about z-scores of above 3 or below -3. Why is that? Based on the graph that you see here. The reason why, guys, because we said 99.7% of the data falls within 3 standard deviation of the means. We don't go above a 3 standard deviation. It's rare. So that's why the z-score 3 means you are 3 standard deviation above the mean. If a z-score is 5, that means you are 5 standard deviation above the mean, which is really very, very unusual case. It's an outlier situation here when you go beyond 3 or below -3. Okay, we will write all of this down, just when right toward the bottom. So I want to do another application of the z-score. Before I do it, if I tell the student in the chat box next week that your score on the test was, your z-score on the test was 2.7, should the student be happy? What do you guys think?
Yes.
Actually, extremely happy. Actually, that could be one of the highest, because when you go beyond 2 standard deviation, I'm a little bit above 2. You know that 2 standard deviation pick 95% of the data. So at 2.7, it could be that the students probably had the highest score, just in the class. But what about if I pick a student and tell that student that your z-score was -1.7? Should the student be concerned? Yes or no? I would say yes, guys. If your z-score is negative, that means you are below the mean. Below the mean is not a good thing. You always have to fight, just to be right at the mean or above the mean. So a negative z-score, as far as test scores, it's not a good thing. You have to have a z-score positive. Worst scenario, keep your z-score at 0, close to 0, which is close to the average of the class, if you want to compare your progress, to the rest of the class. So this is what a z-score is. This is the formula. I'm going to write it right here in a different way. X is the value, mu is the mean, and sigma is the standard deviation. This is another way in the book they write the formula, or they write it like this. This is the mean, but from the sample. This is the standard deviation from the sample. They're pretty much the same. It's always value minus mean divided by standard deviation. Let's do this question together and show you how to use these scores to compare performance on 2 different subjects. SAT vice ACT. So we have 2 students. One student took the SAT and another student took the ACT. We want to see which students can claim that he did better than the other. The SAT is in the hundreds, the score, and the ACT is in the tens. So you cannot compare, apples with oranges this way. But we're going to convert, to z-scores and then compare in a little bit. So let's read this one. Eleanor scored 680 on the SAT test. The distribution of the set scores is symmetric and single peak. That means it's bell-shaped, with the mean of 500 and standard deviation of 100. So let me write down the information. So SAT, mean is 500 and standard deviation is 100. And what was Eleanor's score was 680. And I'll put her name here. Now ACT. Gerald takes the American college testing ACT math test and scores 27. So that's it, Gerald. He scored 27, but let's see what we know about the ACT scores. ACT scores also follows a symmetric single peak distribution, but with the mean of 18 and standard deviation of 6. All right. Find the standardized z-score from both and see which one did better than the other relative to the exam. So let's find the z-scores first, guys. So z scores here. Okay, the formula says the value. Okay, the value is, what did Eleanor score? 680 minus 500 divided by 100. If you do the math, guys, you get 1.8 z-score. Okay, let's see Gerald on the ACT. You see, before I do the z-score, I couldn't tell, guys, who did better relative, just to the exam. The 680, is it better than 27? I don't know. There are two different ways, just of grading, so I couldn't tell. But with z-scores, you will be able to tell. Let's do the z-score for Gerald now. The value is 27 minus 18 divided by 6, which is 9/6, which is 1.5. Now, can you guys tell me who performed better on the test? Was it Eleanor or Gerald?
Eleanor.
Yes, because she had a higher z-score. I can assure you guys there will be a question on the test to probably compare to z-score and tell me which one did better. So this is a higher z-score. Okay. In conclusion, a value in a data set is unusual if it is above 2 or below -2. So if you get a z-score of 2.5, guys, that's unusual. A data value is very unusual if it goes beyond the 3 standard deviation. 3 or z less than -3. So below 3 from the negative side or above 3 from positive side would make it very unusual. So what's usual, guys, that you would encounter in every day? Can someone tell me what should I write here? If z is between what values? -2 and 2. There will be some questions in the homework. You will find the z-score and tell you, and they'll ask you, check if the value is usual or unusual. Well, if the value is between -2 and 2, it is usual. If it is below, outside of this range, it's unusual. For example, let me write a few and you tell me. Okay. The -2.1, guys, it's below -2, so that's unusual. This is between -2 and 2, so that's usual. 1.75 is okay. It's between -2 and 2. This one is also okay. 0 is okay also. It's between -2 and 2. So this is what you guys need to know about Z scores. Any questions about Z scores? Feel free to ask. Let me see if I have any comments here in the chat. All right. Okay, so that's the last part of section 2.5. What I would like you to do, guys, later, we completed chapter 2. What I'm going to do today, if students show up online between 2 and 3 today, I will reinforce what we did, and we can go over some of the exercises in here, the review exercises of chapter 2, or I'll answer any questions. So that's a very good review of chapter 2. So if you still guys have some unanswered questions, feel free to join me today between 2 and 3. I will sign in at 2 o'clock, and I will send you the link one more time to the Zoom meeting for the virtual office hours. And on Thursday, guys, I told you I'll provide you with a study guide for the test, just to have a feel of what the questions are going to be like, and we'll answer some of them. So it's very much, it's just like taking the quiz, but the only thing about the chapter 1 quiz is it's mainly multiple choice, whereas in chapter 2 and 3 will be crunching some numbers. So before we wrap this up, I'm just going to go over some of the questions in the review, and please try to do the ones that we don't answer, so you can come prepared, you know, to the remaining sessions. I will email you tonight the guided notebook for chapter 3. We will start in chapter. We're going to do an introduction to probability tomorrow, and in chapter 3. And then on Thursday, we will talk in more details about the test. Okay. And this is very much, you will see probably questions like that, you know, just on the test. For example, to construct a frequency distribution table, guys, you have to have the class width. That's the key. If you don't have the class width, then that would be an issue, you know, just for you to create, you know, the table. And I want to walk you through the class width and get this started with you. Okay, let's figure out how to do the class width one more time. The class width is the largest minus smallest divided by the number of classes. No, it's 1, 2, 3. For the exam, it's chapter 1, 2, 3. That's why I'm postponing it till Monday. So it's going to be 3 chapters. Okay. What is the largest value here? Can you guys help me figure this out?
75.
Yeah.
And then 67 is the lowest, I think.
All right. We're going to trust you. And then he wants how many classes? 5. Okay. I think I can do the math. And that's going to be 1.6. What happens to 1.6, guys? Goes up to what? Round up.
To 2.
Yep. And let me show you how to construct the table. What I noticed, you know, just from looking at some of the homework, it's just students are not very careful when they count how many in each category. So you have to be very careful. Okay, so we start with 67. Watch, guys. You put the 67 here and start adding the class this way. Don't add horizontally. You add horizontally, you will fall short. So add a 2, 69. Add a 2. Let me just do this. 71, 73, 1, 2, 3, 4, 5, 75. Okay, what should the number be here? 69, what should that one be here? Right below, immediately below 69, it will be what? 68. And add a 2, guys. Make it easy. 70, 72, 74. Now, some students might will tell me, oh, we went beyond the maximum. It's okay. You can go beyond the maximum. Well, 75 is there. That's all I care about. And then, guys, you figure out how many of each category are there, and you just put the frequencies. The relative frequency, let me do 67 to 68. Let's see. 1, 2, 3, 4, 5, 6. Okay, the relative frequency, guys, is 6 divided by 32, which is the total. And if I do 6 divided by 32, (0.1875). Let's say in my math lab, he says use 3 digits, so it will be 0.188. And so on and so forth. You just do the rest. If I look at the next exercise, guys, he's asking you to find mean, median. So that should be very straightforward to do this. So I'm gonna skip this one. Another question, mean, median, mode, range. Range means maximum minus minimum. Variance. Your calculator will not do the variance, guys. So whatever you get on the calculator, let me just do this one and make sure that we understand the use of the calculator. Since this is on my handout, I mean, you could use static runs, but you have to input the data into static runs. So I'm just gonna do it on my calculator. So let's do this. So stat, edit. I'm gonna put my data in L1. Look how I clear L1, guys. I hit clear and press enter. Okay, let's enter the data. 5, 5, 5, 6, 6, 6, 6. Okay, what else do we have? 2 7s, 3 8s, and 2 9s. Okay, I'm ready to find all the answers for you. Stat, calc, one variable statistics. It's in L1. Make sure to change it to L1. Okay. So mean. It's I changed the dates, guys, for the exam. Remember, I was gonna do it on Thursday, but I want to give you the extra time, so I'm gonna give you extra 4 days to prepare for the test. I saw some comments in the chat inquiring about the test. That's why I said it's tentative. That will give you better chance to prepare. So X bar is 6 point. Let's say 1 decimal place, guys. So 6.8. And this is not a population. This is a sample. So median. The median, guys, is, if you scroll down, watch, 6.5. Would you say that both the mean and the median are representative of the center? Yes. It doesn't look like I have outliers here, so they're both okay. Look, they're very close together, 6.8, 6.5. Mode, which data occurs most often? I think it's 6. Range, which is 9 minus 5. Variance, okay, now, it is S, guys, the standard deviation, 1.4. But he wants the variance, so you take 1.4 and square it. Which is S squared, which is 1.96. Okay? Oh, he asked for the standard deviation as well. Sample standard deviation, which is S. Okay. Exercise 4. Imagine that Sue Cash is a female student in your statistic class and she gets a score of 9 on the measure of statophobia. Using the sample mean and standard deviation for the female students that we did earlier, convert 9 to a z-score. Okay, what was the sample mean? The sample mean, guys, was 6.8. That's X bar. And the standard deviation, S, was 1.4. Okay, he wants me to change this to a z-score, to the value 9 to a z-score. Well, here's the formula for the z-score. It's value minus mean divided by standard deviation. Okay, value, guys, is 9. Mean is 6.8. And standard deviation is 1.4. So that's 2.2 divided by 1.4. And let me see what would I get here using calculator. 1.57. Usually these scores are recorded with 2 decimal places, so it's 1.57. Suppose that we wanted to convert the statophobia score to a standardized score system with the mean of 10 and standard deviation of 2. Now he's changing the mean and the standard deviation to 2. He said, what would be the z-score? Let me just do it. The value is 9. The mean, he says, now is 10. The standard deviation is 2. And watch, guys, it will be -1/2, which is -0.5. Okay, now it's all about z-scores, guys. Suppose that Sue is not a woman, so it's not a part of the female group, but rather a man, a boy named Sue. Recalculate his z-score using the sample mean and standard deviation for the male students, which we did. Oh, we didn't do it here. This is the data from the male students, 5, 7, 7, 10. So let's do it. Let me put it into the calculator and find the standard deviation of this. Stat, edit. Okay, I'm gonna clear L2 and put 5, 7, 7, 10. So it's a lot of tedious calculation, guys, but they're straightforward. One variable statistics. Remember, I'm looking at L2 now, so I'll put second and number 2. Okay, the mean is 7.25 and the standard deviation is 2.1. 7.3 and 2.1. Let me write S. And the median here, guys, you can see the median, 7. Again, no outliers. Look, the mean and the median are very close together. They both represent the measure of center. So we got 7.3 and 2.1. I'm gonna go back to my exercise. So it's a score of 9 minus the mean, which is 7.3, divided by 2.1. It's gonna change. As you change the mean and the standard deviation, you will get different values every time. So that's 1.7, guys, divided by 2.1. Let me just do it. 0.81. So this exercise just to show you how to calculate the z-score if we change the values. Okay, the next question, exercise 5, find the 5-number summary. I'm gonna skip this one. I'll let you do it. You should be able to do that one easily. This is the data set. But I'm gonna do exercise 6 and I will stop right there, guys. A student scores 62 in geography test and 285 on a math test. Now the question is, on which test did the student do better? You cannot tell me the 285. Maybe the 285 is out of grade of 500. So probably the students did not pass the test. And maybe the 62 is out of 70. So that means the students did very well. So you could not tell unless if we know how the test was graded. So he scored geography 62. That's X. And the math test, he got 285. The geography test has a mean of 80 and a standard deviation of 15. So mean of 80 and standard deviation of 15. The math test has a mean of 300 and a standard deviation of 10. Okay. Both data sets are symmetric. On which test did the student score better relative to the other students in each class? Convert the test score to z-score. Well, we have to do that. Okay, let me do the z-score for geography. I'm gonna label it G, guys. Value is 62, mean is 80, and divide by 15, which is negative 18 divided by 15, which is negative 18 divided by 15, guys, is negative 1.2. That's bad news, below average. Okay, let's see this one now. Z of math, 285 minus 300 divided by 10, which is negative 15 divided by 10, which is negative 1.5. Okay, the answer for you guys. On which test did he perform better relative to the rest of the class? Actually, he didn't perform well at all because he's below the average. But which one is okay? Which one is bad and which one is worse? Any answers?
He did better on the geography one.
Yes, it did better in geography because it's higher. Negative 0.2 is a higher z-score. Remember that. That's what I'm trying to enforce, guys, the importance of the z-score. When it comes to test scores, yeah, the higher the better. But when it comes to debt, guys, on student loans, the lower the better. You have to understand that sometimes. So it all depends on the situation. Okay, guys, that's all. We will review the rest of the exercises tomorrow before a recap on chapter 2 before I start chapter 3. And I will be around at 2 if students have some additional questions. All right. Make sure to put your name in the chat room so I can keep track of your attendance, please. Thank you.